I'm the chief engineer of the XB-1 program, and I lead a team that's responsible for the design, development, and performance of our demonstrator aircraft. As an airplane guy, I joined Boom to help solve a challenge that's persisted in the 75 years since the Bell X-1 first broke the sound barrier: affordable and sustainable supersonic travel. If these models look fast, it's because they're designed to be fast. They'll operate quicker than the speed of sound. But that speed doesn't come for free. The faster the aircraft travels, the more drag it experiences. You can offset this with greater engine thrust, but that comes with increased fuel burn and therefore cost and emissions. At Boom, we aim to create a sleek, lightweight design that minimizes drag to the greatest extent possible, and therefore cost and emissions. In the 60 years since Concorde was developed, there have been several key advancements in technologies that make this possible: aerodynamic analysis, strong, lightweight materials, and efficient propulsion. Aerodynamics present the greatest challenge in achieving a successful supersonic design, and that is meeting your performance, handling, and efficiency goals while ensuring safe operation at the low speeds required by takeoff and landing. Our aircraft is dominated by design features that enable supersonic flight, specifically the long, slender fuselage, narrow, highly swept wing, and aggressive inlets designed to slow the oncoming supersonic air to the subsonic speeds that the engines require. All of these features, however, tend to have detrimental effects on low-speed flight characteristics. For that reason, many iterations are required to close on a design that enables safe and efficient operation at both high and low speeds. Concorde engineers had to solve these problems by creating designs with pencil and paper and evaluating those designs through extensive wind tunnel testing, which is both costly and time-intensive. Today, using advanced fluid simulation, high-powered computing, and digital design tools, we're able to reduce the iteration time from months to days. And while it's still important to validate our designs through wind tunnel testing, computer simulation has enabled us to reduce that effort by orders of magnitude. Next, XB-1 is primarily constructed of carbon fiber composites. These materials have several key advantages over metals commonly used in the aerospace industry. First, you're able to create large parts that are easily molded to the complex shapes that our aerodynamic design demands. Second, you can then tailor those parts to be strong in the necessary areas and lightweight in the others. And third, these materials are not as susceptible to the expansion and contraction associated with the temperature changes that are experienced during supersonic flight. By contrast, Concorde, which was an aluminum aircraft, grew by over a foot at max speed, and the SR-71 leaked fuel on the runway until its titanium skins could come up to temperature and seal the tanks. By using carbon fiber composites, we all but eliminate these concerns and therefore reduce structural complexity and the associated weight. Lastly, XB-1 is powered by 3 J85-15 engines that produce over 12,000 pounds of thrust. These engines have been ground tested with today's sustainable alternative fuels, and compared to the baseline set with the standard petroleum fuels, performance with these sustainable alternatives exceeded our expectations. As the first privately developed air-breathing supersonic aircraft, the objective of XB-1 is to bring these technologies together into a harmonized design, to solve the complex, difficult problems associated with new aircraft development, and to develop the tools and processes that will carry forward to our commercial program, Overture. But most importantly, it's driven the creation of a team that can solve complex, multidisciplinary problems across the design, build, and test phases of new aircraft development. I am incredibly proud of the team that we've assembled and what they've accomplished with our plane, XB-1.